Hey guys, welcome to another college algebra video. This is the last section in chapter 2, section 2.7 that we cover anyway, inverse functions. And we're going to talk a little bit about what it means to be an inverse function. Not all functions have inverses, so how do we know when to look for them and how do we find them if they do have them? All right, so we're going to first talk about the concept of an inverse function, and then look at some graphs, and then get into the algebra of it. Okay, so an inverse function is a function has an inverse, I should say, if you compose the two functions. Remember last section we did composition. If you do f of g of x and you get x back every time for every x in the domain of g, and if you do it the other direction too for every x in the domain of f, all right, then you have an inverse function. And we write inverses with this notation. Now be careful, this is not a power. This is not the multiplicative inverse, which means flip it over. Okay, so f inverse of x is not the same thing as 1 over f of x. That is not true. Okay, that is absolutely not true. Okay, it is a new concept, and it's the inverse with regards to composition, not the inverse with regards to multiplication. Okay, so that's a really important distinction that you need to be aware of. Let's take a look and see how to show that two functions might be an inverse of one another. Okay, so if you want to check to see if functions are inverses of each other, then what you do is you do what's known as the composition, and you do f of g, and then you got to do g of f also. So here's your f of x, here's your g of x. This is the stuff that we did last section. So if you're struggling with this idea of plugging one function into another function, that's composition, and that was covered in the video for 2.6. So if you take g of x and you plug it in, what does f do? F is 4 times the stuff minus 7, so we get 4 times x plus 7 over 4 minus 7. These 4's divide away, and you get x plus 7 minus 7, which is x. Okay, so you do f of g of x, you get x for every single x. Basically, look at what's happening here. Here you multiply by 4, then you subtract 7. Here you add 7, divide by 4. They are opposites in the opposite order, and so it makes sense that they undo each other, which is what inverse functions kind of, you can think of it like that, as they kind of undo one another. All right, let's go the other direction. G of f of x. If you plug in 4x minus 7 for f, and then you plug that into the x spot right here, you get 4x minus 7 plus 7. That's divided by 4. The negative 7 plus 7 gives you a 0. 4x divided by 4 is equal to x. Okay, so this shows that f and g are inverse functions for one another. As far as we're concerned, we will only ever have inverse functions that go with each other. All right, so we would write that then f inverse of x is equal to x plus 7 over 4, since f of x was equal to this. Okay, so inverses are unique. That's why we can use this notation. There is no other function who is the inverse of f. Okay, so y'all try one. We're going to check to see if these are inverses of each other. Start with f of g of x. See how that goes. And if you get x, then you keep going. If you don't get x, then you know they're not inverses. All right, so take a moment, pause the video, try that out, and we'll come right back and go over it together. Okay, so what is g of x? G of x is 3 over 2x. And again, how do we plug this in? The f of x is 2 times x minus 1 over 3. So whatever's in here goes in where that x is. And so we have 2 times the stuff minus 1 over 3. That's how we think of plugging our functions in. And so we plug in this 3 over 2x. Okay, so let's simplify this a little bit. The 2 divides that 2, and you're left with 3 over x minus 1 over 3. All right, let's multiply the top and the bottom by x and distribute this x to cancel out the denominator here, or to eliminate the denominator. You get 3 minus x over 3x, And that really can't be broken down. I mean, we can break this up into two pieces, and we can even simplify this a little bit, make this 1 over x minus 1 over 3, but that's not equal to x, right? So it's not equal to x, so these are not inverses of one another. So to verify inverses, you have to check f composed with g and g composed with f, but since it didn't work for f composed with g, we can stop. If we did get x, then you'd have to go the other direction like we did in the last problem. Okay, so that's just a practice, and again, everything here is just section 2.6. This isn't actually anything new other than the concept of an inverse, but the skill needed is the composition of functions and working with some algebraic fractions. And so if you're struggling with that, 2.6 is the composition. Simplifying this fraction is all the way back in chapter 1, section 1.2. All right, that's complex rational expressions and stuff, complex fractions. So all that stuff you should be able to do by now. And if you need some help with that, just let me know. All right, so how do we know whether a function actually has an inverse? I said not all functions have them. And so if you can look at the graph of the function, you guys have a graphing calculator, so this is definitely the easiest way to go. All right, if you graph your function and you draw a horizontal line being, straight across, horizontal line, if it intersects your graph in more than one point, then it fails the horizontal line test. Kind of like the vertical line test for functions, this is a horizontal line test for one-to-one functions. One-to-one functions are the only ones that have inverses. All right, so here's two examples. Here we draw the horizontal line. We we intersect in two spots. Okay, that fails the horizontal line test. Whereas here, if we draw a horizontal line, it only ever runs into one, and so this passes the horizontal line test. All right, and so as far as we are concerned, what does that mean? That means that graph B represents a function that has an inverse. Okay, graph A does not have an inverse. And again, the reason is if you are doing the inverse, then basically what's happening is you're switching the x's and the y's, and here if you switch the x's and the y's, you would have 2 points with the same x, and that's not okay, right, for a function. So that's why we need one-to-one functions in order to guarantee that we have an inverse. Okay? All right, now, once we figure out we have an inverse, or if we're looking for an inverse algebraically, we don't have the graph. How do we figure that out? Here's a 4-step process. This 4-step process will enable you to find the inverse of a function. And as you note in step 3, if you're solving for y and you can't get a function out of it, then obviously you don't have an inverse function. But for us, my suggestion is that you test it with the graph first. Use your calculator, graph it real quick, make sure it passes the horizontal line test, and then you don't have to waste your time. If I'm asking you to find an inverse, then you can use the horizontal line test to determine whether or not it exists. But then if it does exist, this is the process to figure it out. So make sure you make a note of this, okay? Let's take a look at how this works. We're going to find the inverse of f of x equals 2x plus 7. This is just a straight line, right? Slope of 2, y-intercept of 7. So we know that passes the horizontal line test, so it does have an inverse. All right, so how do we do this? We replace the f of x with a y. Sometimes you'll be given the y straight out, but if not, you have to put that in there. Now flip the x's and the y's. All right, so now the x is over here and the y is over there. And now we take this new thing and we solve it for y. X equals 2y plus 7. And then we subtract 7 from both sides, divide both sides by 2. And this is clearly just a regular old function, and so we can write the y as f inverse of x. Okay, so that is the step-by-step process. I'm going to ask you to try to do this on a little bit more complicated problem. Again, pause the video and do it. We do have the steps written down for you. Okay, so here's the steps laid out for you. I want you to try to find the inverse. This does have an inverse, okay? I'm just telling you that. I'll give you that. You can graph it to check, but this does have an inverse. And so go through these steps and see if you can solve for the inverse function. So let's take a look here. How do we do this? We replace f of x with the y. Okay. And then we swap positions with the x and the y. In this case, again, there's only one x and one y. So we swap them. If there's more than one x, then you have to swap both of them and you get more than one y, but we don't see that very often. Okay, now solve for y. Well, how are we going to do that? We're going to multiply everything by 3y plus 1, both the left hand and the right hand side. If you multiply it on the left hand side, you get x times 3y plus 1. On the right hand side, this divides away and you're just left with 7. And then if we're trying to solve for y, let's break it out. Distribute out the x, we get 3xy plus x equals 7. And then we're going to subtract x from both sides. And so we're left with 3xy equals 7 minus x. And then, of course, the last step would be to divide by the 3x. And so we end up with y equals 7 minus x over 3x, right? We need to divide by 3x here in order to get the y by itself. And so we get y equals 7 minus x divided by 3x. And so to write that as an inverse function, we just replace the y with that inverse and write 7 minus x over 3x. So that's the process for finding the inverse. You can always check. How would we check our answer? We would check it by doing the composition, and the algebra gets a little ugly. But if you check it if you do the composition, you should get what? You should get x both times. So that's an easy way to check your answer. Obviously, I'll give you the key, but if you're on a quiz or a test, you want to check your answer, that's one way to check it, is to take a look at the composition of f and f inverse and make sure that they, quote, cancel each other out, and you just get back to x. I hope that helps, and we'll see you later.